Please make sure you have your copy of the assignment Calorimetry, High Temperature Measurement. What we'll do is we'll look at how to do the calculations. I'm going to use my data. You can use your data following the same procedures. And if you don't have data of your own, you can borrow mine and you can use them to practice doing the calculations. So as we've done before, the first thing we'll do is we'll take our data and we'll move them onto the back, onto the data diagram, so that we can review and summarize the procedures that we use to collect the data. This experiment actually started with two previous experiments. In the first one we measured the specific heat capacity of the steel, and in the second one we measured the specific heat capacity of some vegetable oil. What the specific heat capacity tells you is how many joules of energy it takes to change the temperature of each gram of material by each degree Celsius. How much energy is involved in the temperature change of that much material and that much change in temperature. You can think of it like it's how much energy is involved in changing how fast the particles are moving in the material. Some materials, like metals, it doesn't take very much energy to change their temperature, but other materials like the oil, it takes much more energy to change their temperature. Water, of course, has one of the highest specific heat capacities of any known substance. It takes almost twice as much energy to change the temperature of water. Okay, so then when we started this experiment, we started by measuring the mass of the steel pieces and the mass of the oil that we put in the calorimeter. We used the thermometer to measure the starting temperature of the oil, and after the hot piece of metal was put into the calorimeter and the temperature went up, we recorded the ending temperature and we calculated how much the temperature of the oil changed. We're going to use that to find out how much did the temperature of the piece of metal change when it cooled from its high temperature down to the ending temperature of the calorimeter. If we know how much the temperature changed and we know where it is when it ended, we can add those back together again to find out where the temperature started when the piece of metal was in the hot flame. The temperature is much too high to measure using a thermometer. A thermometer would simply explode. So when we do our calculations, we have to make sure that we're using numbers from the correct part of our data. The first calculation is asking about the oil, to find out how much heat was exchanged between the cool oil and the hot metal. So all of the numbers that we use are going to come from over here, data about the oil. The second calculation will calculate the temperature change of the metal, and so all of the data will come from this side over here, from the metal. What the two calculations share in common is the heat that was exchanged between the warmer and the cooler material. There's only one heat in the calorimeter, and so we use its value in both calculations. Okay, so the first calculation is about the oil. We'll start by calculating what's the quantity of heat that was exchanged. First, we need to know the specific heat capacity, 2.47 joules per gram degree Celsius. And we need to know the mass, 40.90 grams. And we need to know the temperature change, 72 degrees Celsius. When you multiply these together, let's see, I got a number that I'm going to round to the nearest whole number, 7274 joules. That's the amount of energy that was exchanged between the hot metal and the cool oil. The energy that warmed up the mass of oil by this much temperature change was this many joules of heat. So that heat came from the hot piece of metal. We'll use that value when we do our next calculation. The next calculation will calculate the temperature change of the metal as it cooled down. We'll use the heat that was exchanged in the calorimeter, and we'll divide by the specific heat capacity and the mass of the metal. The specific heat capacity, 0.39 joules per gram degree Celsius, and the mass, 16.14. Now make sure when you do this that you do the bottom math first, 0.39 times 16.14, and write that down, 6.2946, and divide your top answer by the bottom answer. You want to follow those order of operations rules. So 7274 divided by 6.2946 equals, okay, I'll round to the nearest whole number, 1156 degrees Celsius. So that means that when the hot piece of metal was put into the cool calorimeter, its temperature dropped by 1,156 degrees Celsius. That's a tremendously huge change in temperature, indicating how hot that was to begin with. To find out what the temperature was to begin with, we'll add back 1,156 degrees Celsius plus the ending temperature in the calorimeter, which was 91 degrees Celsius, to find out what was the starting temperature. So 1,156 plus 91 equals 1,247 degrees Celsius. That's pretty darn hot.